I am Dr. Vibhore Rastogi. I am Associate Professor at the Department of Paper Technology, IIT Roorkee. So, during the course of my presentation, I will briefly explain what is paper, what are the different cornerstones of paper technology, why was paper invented, something about integrated paper mills, non-integrated paper mills, specifically focusing on forming, pressing, drying, calendering of papers, then why cleaning is also an important part in this segment, some journal safety aspects, and the recent trend in in paper mills. So, what is paper? In a very simple single sentence, a paper is a felted sheet of natural fibers. So, these natural fibers can be obtained from wood, can be obtained from agro waste materials, or anything that is of natural origin. If we look paper from the two-dimensional side, from the top side, we can see that it is composed of randomly oriented fibers at the surface. But is it really a two-dimensional material? It is not, because it is a three-dimensional material, because there is a thickness is also involved. So, in this diagram we can see even a thickness that is involved. So, this is a three-dimensional figure. So, here each and every fiber is actually joined using hydrogen bonds, and therefore, this material is also considered to be as a viscoelastic material. Usually industrially, the paper is produced from roll to roll manufacturing process from a water suspension, but at the same time we can also produce paper manually in a sheet by sheet manner. So, where handmade papers are actually produced. So, simply if I say what is a paper making, so paper making is a very simple process where you start with wood. Let us say we just need to disintegrate the wood. The very first figure that you can see here is a wood under the optical microscope. The moment you disintegrate the wood by any means, by mechanical treatment or by a chemical treatment, we will be able to liberate the fibers. In the middle you can see the fibers. So, these fibers are floating in a aqueous medium, and then what we need, we just want to remove, we want to keep removing the water from this aqueous suspension of fibers, and at the end we will lead the paper. So, there are three cornerstones of paper technology, as very correctly said in the initial in the morning session as well, that all the things like raw materials, starting from processes, how we are preparing the raw materials, different machinery to produce the paper, forming, converting, and to the final paper properties. All these three things are very much correlated. For example, if we want to produce a paper that is very strong in nature, so we have to choose our raw materials correctly. At the same time, we have to choose the process that is used to pulp them, to produce them. Then only we will going to get the paper properties with the required strength. Similarly, if we change anything, either the raw material, either the processing step, we can definitely see the effect of that thing to the final paper properties. So, we really have to be very sure what we are changing, if we are changing raw material or anything in the process. So, if I ask this question, why was paper invented? So, basically man has a deep and a basic need to communicate. We like to talk, we like to exchange the information, we want to pass the knowledge from one generation to another. So, for that purpose, what ancient man did, he used to write on the walls, stones, but it was difficult to carry from one place to another, or maybe from one generation to another. It was difficult to carry, because the ancient man used to travel a lot. So, they come up with the idea of making the clay tablets that would a little easier to carry along, but these clay tablets are heavy. So, therefore, it was again difficult. Then the ancient man came up with the idea of writing on leaves, bark, wood, and these kind of materials. So, the precursor to modern paper is papyrus. So, the word paper is actually derived from papyrus. This papyrus is an Egyptian invention, and this shrub, this small plant that you can see over there is known as Cyperus papyrus. So, from this was the first plant used to produce a thin sheet like structure. So where the core, the inner core of the stem was stripped off, cut into the longitudinal thin strips, and then finally we can have this kind of a structure as you can see over there. And after several hammering, drying, and polishing, the material was able to write. But still, it was not the exact paper that we know today, and it resembles more or less like a plywood than a paper. Then, if I talk about exactly when the paper invented, somewhere in 105 AD, a Chinese known as Kai Lun, he experimented with several different kind of materials like hemp and mulberry, like how to soften or liberate the fibers from these kind of plants. This is the main thing, how to liberate the fibers. Once he was able to liberate the fibers, he was able to mix it with water, and then through a simple filtration process using a screen, all the fibers were collected and then just dry either in the sunlight or by any other means, and this is exactly what we know today, the paper. Here the secret stayed in China for centuries, but smuggled to Europe by Arab traders sometime after the 10th century. So here the thing is that paper was a very important invention, because in order to spread the literacy around the whole world, paper plays a major role. So here if I like to separate out the paper technology, the science of making the paper, there are several steps. The very first is cooking, as you can see over there. So here we just need to cook the fibrous material into some sort of chemicals or something so as to liberate the fibers. Then we have to clean it, because we want to get rid of the chemicals that we have used for cooking. Then we need to perform beating. So beating is done to make the fibers more homogeneous. We have to make the surface area of the fibers little bit more so that they can make a better bonding. Then finally, the paper making, where we have a kind of a screen, and there is a container filled with a very watery suspension of the fibers. So this watery suspension is something very close to or even less than 1%. So that means less than 1% of fibers are present in the container, and rest is the water. That means around 99% of the water is there that we have to get rid to make a paper. Then pressing is also involved here in order to get rid of the water, and finally drying to evaporate almost every water molecule in the paper. I luckily found one video where it is about handmade papers, how the handmade papers were developed in Asia. So please have a look. Please bear, it's around 3 minutes long video. So this lye is nothing but sodium hydroxide. Okay, so this is how the handmade papers are actually produced even today. So, but if we talk about industry, how we can produce these papers industrially, we just have to keep all those things intact and just put the same concept here at the industrial level. So, we have two different types of paper mills. One is integrated paper mill and the second is a non-integrated paper mill. So, the paper mill that is having the facility to pulp and to produce the paper at the same time, it's considered to be as an integrated paper mill. So, there are several steps involved: debarking to remove the bark of the wood, then chipping to reduce the size, pulping to liberate the fibers, washing, bleaching, refining, blending, forming, pressing, drying, calendering and winding and trimming. So, these all kind of operations are very much necessary to produce a paper. Basically the all 5 steps, initial 5 steps: debarking, chipping, pulping, washing and bleaching. If we are doing this thing in a paper mill, we consider that paper mill to be an integrated paper mill. So, but whereas the objective of any paper making, whether it's done in integrated paper mill, non-integrated paper mill or sheet by sheet fashion, the objective would be to have good formation and good paper properties, high capacity and low cost of the production. So, here I will focus mainly on forming, pressing, drying and calendering, because rest of the topics will be covered by other speakers. So, when we talk about non-integrated paper mill, we have still the same paper machine, but the initial processes were not there. We directly start with a pulp known as bale or market pulp, or we can also use a recycled paper. We just have to repulp it, make it a slurry as a pulpable form, and then after refining, cleaning, it's ready to go into the paper machine again. So, if we talk about the paper manufacturing, I am taking a very basic example of a paper machine known as Fourdinier paper machine. So, in this paper machine, you can see there are several different sections. The very first section is known as forming section. The first green color kind of box is known as head box, that is used to deliver the pulp to the forming section, and this former is nothing but a mesh, a wire mesh, over which we will put the watery suspension of the fibers, and the water will drain down and there will be a very thin sheet of the fibers after over the forming section. That will be later pressed using the pressing machines to squeeze further extra amount of water as much as we can, because we don't want to just dry the paper after the forming section, because it will require so much of the energy to get rid of the water. So, therefore, it is very necessary to press the water out from the initial wet web. And the final section is a drying. So, drying again has a different kind of strategies to go with, like we can even go for air drying, but this is not feasible for most of the application, because this is only specific for the tissue application, where we don't want to have the very high density. We want the bulk over there. But once we have this drying section, then we can have calendering, and then finally at the very end you can see whatever we produce, we can collect it into a reel form, and it's ready to transport now. Now, this is again a video of a head box.
A head box has 4 basic functions. 1. To deliver the stock uniformly onto the forming fabric, also called the wire, in the cross machine direction and the machine direction. 2. To create controlled turbulence to reduce fiber flocking and develop a uniform fiber distribution across the wire. Flocking is the tendency of fibers to clump together. 3. To coordinate the speed of the stock jet with the speed of the wire. This relationship plays a major role in sheet formation and fiber angle or orientation. 4. And ensure that the flow of stock from the slice opening strikes the wire at the correct angle and location.
So, as you could see that it seems to be very simple, but there are so many of the technical know-how that is being involved. So, if we look what are the targets of the forming of the wire sections, the very first thing is that Initially we started with the pulp suspension of less than 1%, so we have to go up to around 20%. That means we have to get the sheet should contain 80% water now, not the 99% water. So this is the first target of the wire of the forming section. Then we want to retain as much possible material on the wire. So therefore the wire should be designed in a way so that we can have a better retention of the fibers or of the additives. Then this forming section should also give us even sheet structure, because we do not want to have some patches here and there that will deteriorate the paper property at the end. And then very important thing, we want to have a paper that is free from defects like pinholes. So the process is very simple. There is one sieve involved, or you call it wire, you call it sieve, it's fine. We started with a mixed slurry, and we tend to filter the slurry through this wire, and after some time we can have a very thin wet web. And this is how these fibers are actually look upon the wire. So here are the different concentration of the fibers over the wire. Now again one more video on sheet formation.
To better understand formation and how it is established, it is useful to understand fiber flocks. A flock is a bundle of fibers that forms due to physical entanglement and attractive forces between fibers. A flock can be as small as 4 fibers, a microflock, or it can consist of a network of fibers and fiber bundles, a macroflock. To optimize sheet formation, it is important to keep the fibers in the paper-making stock from flocking together excessively. Dilution, turbulence, and shear forces can be used to prevent flocculation. Because dilution is limited by the dewatering capability of the former and economics of handling large volumes of water, the stock delivery system and some forming section elements must create shear and turbulence to keep the fibers dispersed until the sheet forms.
Another aspect of paper making is that how your fibers are actually oriented within a sheet. That will dictate about the strength of your final paper. So and how we can do that, how we can orient each and every single fiber is through the jet to wire speed ratio.
If the stock jet speed is greater than the wire speed, the jet to wire ratio is greater than 1. In this case, the fibers will tend to align in the cross machine direction, increasing the sheet strength in that direction. Sheet formation and sheet appearance are both impacted by the jet to wire ratio. When the jet speed and wire speed are almost equal, when the ratio is close to 1, the fibers will be well distributed and randomly oriented in the sheet. Somewhere around the ratio of 1, the machine direction and cross machine direction strengths will be about equal, creating a square sheet. Formation and appearance are both positively affected by the squaring process.
So we have different possibilities like to orient our fibers. Like the first case where the jet to wire ratio is more than 1, where the fibers tend to orient themselves mostly in the cross machine direction. Then jet to wire ratio is when it's less than 1, most of the fibers tends to align in machine direction. And something in between, when the jet to wire ratio is 1, most of the fibers are randomly oriented, but we have a kind of a thumb rule that if this ratio is somewhat between 0.9 to 1.04, we can have the paper with the acceptable formation. Now regarding the pressing, as I said that we want to get rid of the water at every stage. So here we have the pressing done with the help of rollers, and here you can see some rollers, and also you can see a felt. So felt is nothing but a sponge like material, because the moment you get rid of the water after squeezing, the water should get first absorbed into this sponge kind material. So that is felt. So this step is very much required in order to get rid of a huge amount of moisture that is present in the wet web before it enters the drying section. This pressing is also going to help in compactation of the wet web. That will also going to help in reaching the good mechanical properties as well. So before getting the paper at this section, the paper is at around 15 to 25% solid content, but afterwards it should leave around 40 to 45%. One more video.
The water removal process in a conventional roll press nib occurs when the sheet and one or two felts pass between two rolls pressed together, rotating in opposite directions. The amount of water removed in a press nib depends on two factors: nib pressure and dwell time, the time the sheet is exposed to that pressure. Water removal from the sheet occurs in two phases. During the compression phase, air is forced out of the sheet and felts, and the nib pressure forces water from the sheet into the felts. During the expansion phase, the felts continue to absorb water from the sheet. The sheet reabsorbs some water, or re-wets, as it exits the nib. To minimize re-wetting, the sheet is separated from the felts as soon as possible after the nib.
So then the last section of this paper machine that is very important, drying, because at this point we can get rid of the maximum amount of water. Usually we do not get rid of 100% amount of water, because again the paper will going to capture the moisture from the environment, so it is not advisable. So we can reach only up to, let's say, 95% of the moisture removal. So here initially after the pressing, we get the paper with a solid content of 40 to 45%, and the remaining amount of the water will get removed using the drying section. So in paper making, the drying is having the two main components. First is a heat transfer, because paper is in directly contact with, let's say, either a heated cylinder or in a hot air environment, where because of the heat water will evaporate, and at the same time we have to give some room for that evaporated moisture to get away. So that is nothing but the mass transfer. So this heat transfer and the mass transfer, both are the very important phenomena during the drying process. So here if we talk about the drying, we have different possibilities. The first would be to use a MG or the Yankee cylinder, which is a big cylinder on which your moist web is pressed, and the paper will remain over there until unless the paper is dried completely. And the second option would be multi-cylinder drying, where we have the several dryers, several cylinders, where paper is keep on traveling from one cylinder to another until the paper is dry. One more video on drying.
On a paper or board machine, the drying process involves both heat transfer and mass transfer. Heat transfer is the movement of thermal energy due to a temperature difference. In multi-cylinder drying systems, the driving force for heat transfer is the temperature difference between the sheet and the dryer cans. This process is called contact drying because the sheet directly contacts the dryers. Heat transfer occurs when the steam condenses inside the dryer can and gives up its latent heat to the inside surfaces. The heat energy from the condensing steam is then transferred by conduction through the dryer can's cast iron shell to the sheet. Because the steam inside the dryer is saturated, the steam temperature is directly related to the steam pressure.
Then the last step that which is an optional step, calendaring, but most of the papers require this. This is known as calendaring. This is nothing but just ironing the paper. So just ask yourself, what would happen if you iron a paper? You can see some sort of shining on the surface, and that would exactly what we need to, especially to make the paper more smooth, homogeneous, and that would be even good for the printing purpose. So we want to smoothen the paper with the application of pressure and the heat, And what would happen? There are again some rollers involved, as you can see here. Either one or two rollers can be heated, where when the paper goes in, it comes out to be smooth with some compactation. So the sheet will reduce in thickness, the variation in the thickness will be even out, and it will impart smooth and the glossy surface. It has some positive effect, like the smoothness will go up, gloss will go up, absorption and porosity will go down. Now this is like if the paper is tissue grade paper, then this absorption and porosity reduction is a negative step, but for other grades it's a positive. Caliper control and two-sidedness control. At the same time, there are some negative effect as well of calendering, like the bulk and stiffness of the paper will reduce, strength properties will go down little bit, opacity and brightness will reduce, light scattering will reduce, and the cost is also increase. And this is how the surface of the fiber or the paper looks like after the calendering. So as you can see the first figure, this is uncalendered paper. All the fibers are more or less like a round shape, but after calendering, or if you keep on doing the calendering, it's known as super calendering. The surface is more homogeneous, more flat. So this is exactly what we need for printing application especially. One more video on calendering.
On single nib calendars, operators typically have control of three parameters to adjust nib pressure profiles: the front load, back load, and crown deflection. The front and back loads create the overall nib load, while the crown deflection affects the nib pressure profile. These three parameters can be used to control the caliper profile of the sheet as follows. If both edges are soft at the reel, because the caliper is low on the edges, increasing the roll deflection will increase the caliper at both edges without changing the overall nib load. Conversely, if both edges are hard, the roll deflection can be reduced.
So then the cleaning and the wire, cleaning of the wire and the press felt is also a very important uh, segment for the paper technology, because what would happen, for example, if the wire, as you can see here, is blocked by a sticky material, it's usually come from the recycled recycled paper, because we do not know what is inside that paper. A lot of sticky kind of material are there that is being deposited over the wire. So as you can see, if we make the paper out of this kind of wire, then we will have the pinholes, because fibers will not going to deposit exactly at the place where the stickies are. Or if we have the deposition of the AKD wax on the wire, then we will compromise the drainage. So both the things are not advisable. So it's very important to clean the wire or the felt time to time, utilizing several showering techniques like flooding, lubricating shower, high pressure shower, or using some chemicals. Now this is about press felt cleaning.
Press felts do not typically wear out. Instead, they are usually replaced because they have that their dewatering capacity is insufficient. It is the job of the felt clean and conditioning system to maintain the felt's void volume and caliper or thickness. This allows the felt to absorb and then release water uniformly during press operation.
Then a very important aspect is the safety. So here are the few of the things that we need to take care.
Papermaking and paper converting facilities have many dangers, including pinch points, nibs, sharp surfaces, hot surfaces, slips, trips, and falls, airborne particles, high noise levels,
So here we can see a lot of places in a paper mill are actually wet, and it's very at somewhere the water is even dripping from from the top, so it's very risky for the persons working over there. So I always say that safety and safety is the first. We only have one life, so we should really take care of our person's safety. And then the last thing about some recent trends in paper industry, as we all know that this printed media is being replaced by electronic media. So the margins in printing and the writing in the printing industry is not that much high. So we have to think something out of the box. Cost efficiency is always the main challenge in any paper industry. Now new concepts like biorefineries are come up, where the waste material like the lignin, hemicellulose, these kind of things are already being extracted from the stream and utilized for some different applications, like even we can produce some biofuels, some biochemicals from the waste material of the paper industry. Then the material availability is also a very challenging thing these days, because the cost of the wood is getting higher, and it's having some a lot of competition with other sectors as well. So therefore we want to have the species either that can be fast growing, or we need to find some alternative raw materials like agro waste materials. Sustainability is all around everywhere now, so we have to be really careful. We have to keep on using some renewable resources for energy generation. Then in order to maximize the profits, globalization is a one way to keep on exporting your materials, some utilizing low cost raw materials. Energy conservation is something is a very at the top, how to conserve the energy, because it's a very energy intensive operation, because we have to keep on evaporating the water or these kind of things, so we have to be really careful. And finally, there are several challenging or very exciting options these days, like to go for the packaging kind of grade paper, specialty paper, some composite materials, and also the hygienic segment. So all these things seems to be very exciting opportunities for the paper industry. So with this, I would like to thank you for your kind attention, and if you have any questions, please free to ask. Sure, sir.
What are the retention aids you were talking about? Uh, you said there are certain aids added to the pulp to retain the pulp on the wire.
Yeah.
Shall I put all my questions together or one by one?
As you wish, sir, but maybe one by one would be good.
Okay.
Yeah. So, sir, there are several, like if we talk about the additives, there are different kind of additives, process additives, functional additives, and we do not require this retention aid every time. But yeah, they will definitely help to make a little bit flock of your fibers, because when your fibers are, like if you are having the fibers, they are just swimming here and there, there are the chances they can drain out. So these retention aid, what they do, they keep the fibers little bit together. They make small flocks so that they will not pass through the sieve or pass through the wire.
So are these some type of polymeric coagulants?
Yes, yes. Mostly they are like there are two segments here. Like we cannot just use coagulants. We have to use coagulants and flocculants at the same time. Coagulants will going to neutralize the charge, and flocculants will going to make the flocks. So both these things have to be work together.
So they are added. Where are they added? Are they added
In the stock.
in the stock?
In the stock. Once we have the refining done, this kind of bleaching done, when we have everything in the stock, in the water suspension, at that time you can add.
Okay. So first we neutralize the charge. So first we add the coagulant. Then after some time we add the.
Then the
right.
flocculants, yes.
Okay. Okay. And see, when we from the head box, when we put the pulp on the wire, and from the wire it goes to the press section.
Yes.
So on the wire, it, as you said, it is about 1% or 20% is the solids.
Around 20%.
20% solids are there. So does this film go on its own, or it has some supporting sheet still when it goes to uh,
Like
the
you mean
press
when at the time of transfer, sheet transfer,
as type of sheet
from the
transfer.
forming to the pressing, or
Yes.
to the pressing to the drying.
Correct, correct.
Yes, there are some supporting sheets as well, and there are some a kind of a suction systems available that used to suck the sheet and just transfer it to the felt.
Okay.
And exactly at that point we have most of the breakage. So it's a very crucial stage, because at that point the wet strength that is in that wet web is not that much high, because it's not being pressed. Although it's having some chemicals as well. Like initially, I guess in the morning session someone asked that what would happen about the tea bag if it's go into the water, why it's not disintegrate at that moment, because of the wet strength additives. But those wet strength additives will going to work only when you dry the paper. Once you dry, they cure and make a polymeric network, and then the paper will not dry. But it's not applicable in this section.
You talked about MG and Yankee cylinder. What are these types of cylinders?
So,
What are these?
so basically, this Yankee is a type of a cylinder that is being used in tissue manufacturing. When we produce a tissue paper like a toilet paper, that whole the process is completely the same like a conventional paper making, but only the drying is little bit different, and at the same time there is a process known as creeping. You see that you can easily stretch the toilet paper. It's only because of that creeping process where we put a doctor blade. There is a blade and there is a cylinder. The cylinder is keep on moving. You put one blade and the paper will tear apart. It will come off. So we break the bonds of the paper intentionally so as to make it bulky.
Okay.
So that is a big cylinder known as Yankee cylinder, that is specific for the tissue manufacturing. But for the paper manufacturing and these kind of things, we have to use a multi-cylinder system, where we gradually keep on increasing the temperature, because if we increase the temperature too quickly, the wet paper will stick to the cylinder.
Okay, thank you. And one more. These there are something known as the recovery boilers.
Yeah.
We hear about that. What are these recovery boilers? I mean, what is the fuel, and is it the lignin which goes into the burning, or what is it?
Yes. So basically, this was just the paper making. But apart from paper making processes as well, there are some other processes as well. Like after the pulping section, in pulping, what we do, we usually dissolve the lignin that is being present in the plant cell. So this lignin is nothing but a cementitious material. It joins the fibers together. But as I said that we have to liberate the fibers. So when we want to liberate the fibers, we have to dissolve this lignin. And this lignin now goes into one system. So that system is known as now black liquor. So now what we do with that black liquor, we cannot throw that black liquor into the water basin. It's not allowed according to CPCB. So we have to somehow get rid of the black liquor, and at the same time there are a lot of chemicals also present in that liquor. So recovery boiler is a system, or I should call it a chemical recovery system. In this chemical recovery system, this boiler is one component, where after concentrating the black liquor, so black liquor is not that concentrated initially, but we have to concentrate it up to the level of around 60 to 70% solid content. It will be very viscous. The moment it becomes very viscous, then we have a recovery boiler where we will spray it. We spray it and everything will burn. Everything will burn, and all the inorganics that is present in there, like all your chemicals. Basically, if I talk about this craft pulping, so we have this sodium hydroxide, sodium sulfide, and lot of other components like sodium sulfate, sodium thiosulfate. All these things will go into the basin now after the burning, inorganics. So that inorganics is nothing that we want to reuse. So now we will again put some sort of water from some other process. We mix it and we call it now a green liquor. Then this green liquor will go again to a causticizing plant. From there it reconverts into the white liquor, all the chemicals that we have started with. So this is the whole chain of the processes.
Okay, thank you, Dr. Vibhore. One last question is, what all are the water inputs to the in the process, and what are all the water outlets. There are, I believe I've seen few mills. There are a number of places. There are some showers. There's something somewhere where water goes in, and there are many places where water comes out. Can you give
Yeah.
some light on
So,
that?
as you might very well aware that this paper industries, they are very much water intensive process. Lot of water is being used because when we are using 99% of the water at the very initial stage, and we have to get rid of that, we cannot throw it off. So, I guess you want to know, are we using a fresh water, or where we are actually throwing rest of the water? This is what you meant?
What I mean is, what I want to know is the complete water cycle. Wherever we put fresh water, or we put recycled water, or recycled treated water. So, is there any diagram you can show us or
I can
explain?
share you with.
Okay, yeah, that
I
would
do
be
not
great.
have it right now,
Yeah,
but
that
I do have it in my lectures.
Sure.
So I'll be very happy to share you with
yeah,
all
that
this
would be great.
information.
Wonderful. Thank you very much,
Thank
doctor.
you.
EOP stage water is goes to the ETP plant, right? And that is very harmful leaker, say water stream line, and that goes to the primary clarifier and aeration tank, and then carbon filters, and treated there for the norms as per the CPCB. Otherwise, all steam line water recirculated to the whole system.
So I have two questions here.
Yeah, sure.
Firstly, thank you for the presentation. It was very, very good. All the videos were very helpful. My first question is regarding what is the industry standards on the dryers, screens, the felts that you speak about which require to be cleaned. What is the industry standard on that? Like how often should you be changing these?
Again, depending upon the type of application of the type of paper you are producing. For example, if you are producing, let's say the this paper from the recovered fibers or the secondary fiber, they are the most dirtiest fibers. So, for example, if I talk about now the lifetime of the this wire section, so it's you can consider it to be something around 2 months or so. After 2 months, we have to change it. But again, if the process is very aggressive, or there are a lot of stickies that are continuously been coming, so maybe 1.5 months is also sufficient. And regarding the felt, something around 1 month or so, we have to keep on changing, because it's difficult to clean the felt, but a lot of these kind of materials, stickies, inorganic materials that we add in the papers used to clog the pores. So and the felt will lose its water absorption capacity.
If you had to choose between the felt, the screen, and the wire, which would be the most critical out of the three to ensure that you're replacing it in a timely manner?
Actually, all these things are important. We cannot choose anyone. Like we need the wire to form, we need the felt to press, and what was the third one?
And the screens for the dryers.
For the cleaning,
dryers,
you mean?
Yeah. No, for the dryers. When you're in the dryer and you have the paper on the screen,
Um,
in the multi dryers.
I guess you meant the fabric,
Yeah.
dryer fabric.
Yeah, dryer fabrics.
Yeah. So we need to have all these three things.
Okay.
It's
And I had another question. This was regarding the nip pressure and dwell time of the pressing.
Yeah.
Is there a relation between the two? Because I think I missed out on that bit when you were speaking of it. What is the relation between the two? Is there one that should be longer, shorter, or are they related to each other? How
yes,
does that work?
these two things are related. Like maybe I can send you a more detailed version of my
That would be
presentation
nice.
later
Yeah,
on.
that would be good.
But just to have a basic idea, like it's something like the sugarcane pressing machine. We have two cylinders, and here in between we have the paper, and the washer is continuously pressing out. Now the thing is, we call this thing where the two cylinders touch each other, we call it nip area. And if you see, it's a very small point. So here the paper stays for the duration of microseconds.
Correct.
around 10 to 20 microseconds. And if we want to maximize the time period that the paper stays in there, either you increase the number of presses or either you change the press to another press known as shoe press.
Okay.
So here the surface is more or less like curve,
Yes.
like this, the bottom of the curve. So there the paper can stay up to around 300 microseconds.
So your dwell time is the time spent under the nib.
Under the nib, exactly. Under the nib, under the load.
Okay, got it. Thank you.
So, so then I would like to thank, okay, I guess we have one more question left.
One small point, whatever felt are used in the paper making process, is there woolen felt or cotton based felt? What is the type of material is used?
Filter you mean?
Felt, fabric felt.
Felt.
It is made of wool or maybe cotton. What is the material
No, no,
actually?
usually it's polyamide and the polyester. Because the thing is, if you want to have a wool kind of materials or the cotton kind of material, it cannot get rid of the water. Or it can absorb the water, but we even have to get rid of the water so that it can be reactivated again to absorb. So we have to use this polyamide or this polyester kind of material to make this felt and the wire.
And one more point, during the nip pressure, when we are applying the nip pressure to remove the excess amount of water around 70 to 80%, is there also application of a heat along with the pressure so that it can little bit giving some drying effect along with the removal of water?
Usually if the system is keep on running, it is having some kind of a heat. But as far as I know, we do not give heat exactly at that point, because the felt is also involved. Although the felt can sustain temperature of maybe around 120 or something, but I'm not really sure if we can have the heat exactly at that point.
Okay. Thank you, sir.
Okay, with this, thank you very much for your kind attention.